Hey everybody, today we're going to be talking about some. So we're going to be talking about the real numbers. We're first going to identify or define in details what real numbers are before we move on to learning the signs. Basically, this is about the signs, all the signs of addition, subtraction, multiplication, and division. We're going to learn those today. So far we've done, typical problems with basic addition, subtractions in the order of operations, also decimals and fractions. Today we're going to learn how to deal with different signs and various situations. For example, when you have something like this, we're going to learn how to do this: -2 + 5, or 2 - 9, also maybe -1 - 3. So we call these signed numbers. So we're going to learn how to do all the operations, not only addition and subtraction with these. So basically going to learn the rules of the signs. Okay, so all this we're going to discuss in detail. But before that, let's first learn what real numbers are and define those. So real numbers, what we call the set of real numbers, is basically a group that contains all the numbers in different type, forms and signs, and for example, fractions, decimals, positives, negatives, powers, all those. Basically every number you can think of right now is basically called a real number. A real number, and they belong to a set or a group called the set of real numbers. They have this symbol, it's like an R, the two vertical lines. That's the symbol for real numbers. So it's basically all the types of numbers, including basically all the numbers we've seen so far. So that includes natural numbers, which basically means numbers that go from 1, 2, and 3, and so on. And also whole numbers. Whole numbers basically start from 0. So natural start from 1, but whole numbers start from 0, 1, 2, 3, and up. And after that, we have integers. Integers basically are these numbers in addition to the negatives. So we take these, and in addition to that, we have some negatives. So positives here, negatives on the other side, and 0 in the middle. So that's integers. Then we add in, when we introduce the decimals and fractions. Decimals and fractions added to this, we get a new group called the group of rational numbers. Rationals or rational numbers, which basically again includes all the above, plus all of these basically, in addition to, of course, fractions, and decimals. Okay, so we talked about decimals before, talked about fractions. When we divide fractions, as we saw, we get some fractions. I mean, when we divide fractions, we get decimals. For example, if you divide 1/2, what's 1/2 as a decimal? 1/2.
0.5.
0.5.
That's right, 0.5. What about 1/3? When you divide it, what do you get? 1/3.
0.25.
0.75.
Nope, that's not right. 1/3 is
3.
not 3. It's 0.333. It's one of those divisions that don't end. Okay, so sometimes when you divide, the division ends with one decimal, maybe two or more. This is one of those that keeps going. So this is a non-ending decimal, or in other words, a repeating decimal. So the 3 keeps repeating over and over again. Unlike this ends exactly with 1 digit, no remainder left. This one, every time you get a remainder of 1, you add 0 to it, and then you get again a remainder of 1 and so on. That's why it doesn't end. So this doesn't end, and the 2 keeps repeat. Sometimes you may have 2 digits that repeat, for example, 17, 17, 17. Just an example. Or it may be 3 digits that repeat. So there's some pattern in which the numbers are repeating. So 3 or 2 digits or 4, whatever. So we have basically 2 types of decimals when it comes to rational numbers. Basically ending decimals like this that ends, or repeating decimals. These just could keep going and going infinitely. So we call these non-ending decimals. Okay, so that's the other group. And there's one more group. It's basically the opposite of this. So here we see that the decimals either end or repeat. Sometimes they never end and they never repeat. Basically the opposite of this. They don't end and they won't repeat. Just keep generating some random digits here. So that would be the opposite of rational numbers. What is the opposite of rational? The opposite of rational.
Irrational.
That's right.
It's going to be all of that in fractions.
It will be basically irrationals. Now this one is all the above, but the irrationals are basically by themselves. It's just a few, it's a group by itself of the numbers that do not fit any of these criteria. So irrationals basically are the opposite of rationals, meaning the opposite of this. Non-ending, non-repeating, non-ending. It doesn't end and it does not repeat. So non-ending, non-repeating decimals, and those we call irrationals. I'll give you an example. The infamous number pi, which is equal to 3.14, actually has billions of digits, billions of decimal points, random ones. There is no pattern, just the random numbers that generate. For example, let me put this in the calculator. I'll give you some of them. So we have 14, 15, 92, 65, and so on. There's so many of them. Yeah, this is one of those magical numbers. So many decimal points. At this point, I believe last time I checked, it was in the billions of numbers here. If not, maybe the precision keeps increasing, but it could be in the trillions anytime. So not, I would assume or estimate. So as you can see, non-ending, non-repeating, just random numbers. Same thing also happens with radical 2, or the square root of 2. Let me put this in the calculator to give you some digits. So that's 1, so 1, 41, 42, 13, 5, 6, and so on. So as you can see here, these digits are random. They just keep going and going, and there's no pattern. Unlike here, we have a pattern, maybe 1 repeats every time, or 2 repeat, or 3, but there is no pattern here. So same thing happens with radical 3, radical 5, radical 7. Basically, the numbers that don't have a square root, a perfect square root. For example, this one is okay. Then the square root of 9 is 3. So that we know. It's not a decimal. It's not irrational. It's actually irrational. This is fine. But some of them They don't have a perfect radical like this. For example, the square root of 2 or the radical of 2 is 1 point this, and so on. So that's basically what the group of real numbers is made of. So natural, again, they start from 1. The whole numbers start from 0. Integers include the positives, the negatives, and the 0. No decimals or fractions, but the rationals, that's the group that contains all of this, basically all the above, because any of these numbers can be turned into a rational. For example, if you have 3, you can turn it into a fraction, into a decimal easily. So 3 is basically 3/1, or you can say 3.0. It's the same value, but the format is different. So all these numbers here are basically rational numbers. So they have ending or non-ending decimals. Ending like this, or the ones that don't end. If something is the opposite of this, or the opposite of rationals, that is irrational. So this contains all of this, but this is a group that's by itself. This is not included in any of this. It's just a group by itself. Naturals are part of the whole numbers. The whole numbers are part of the integers. Integers are part of this. But rationals are not part of the irrational. It's a separate group by itself. So next time you hear real numbers, that's all it means. It means all these types of numbers. So now that we know what rational numbers are, I mean, not only rationals, but what real numbers are, let's see how to work with them. Let's see how to do the various operations as I showed you earlier with different signs, what we call basically signed numbers. All the rules of the signs we're going to discuss today is in details, and they're very important. So first, let's talk a little bit about the number line, because the number line helps us understand basically the real numbers, understand addition and subtraction. So let's first talk about the real numbers and also the number line and comparing the real numbers. So the number line is basically a straight line like this, straight vertical line or horizontal line. And on that number, we basically put some integers. We put some integers. Actually, not just the integers, but at first we just put some integers like these. But technically, we can put any number, any real number on it. But for the first sign, for the line itself, it's like a ruler. We just need a few numbers here. It's like a ruler or a measuring tape. We only put some numbers, not all of them. We don't put the decimals or anything unless we need them. So we have some positives here. We have some negatives on the other side. And so on, okay? So that's what we have. And on this number line, we can put any of these numbers, regardless of the group they belong to. We can basically graph any type of these numbers. It can be here, even though we only see integers here, but we can put any other numbers, whether it's a positive number, maybe a negative number, could be a fraction, could be some decimal, like this, 2.5, maybe the pi itself, the pi that we can also graph it here, or even something like this, an exponential number like this. So all of these we can graph. So for example, 3 is clearly here. It's a positive number, so that's 3 is right there. -2 is negative, so it's going to be on this side. Then we can also put this number 3/2. Where do you find this number on this number line? Where exactly do we find it? Or between which numbers?
In between 3 and 4?
Not between 3 and 4. What is 3/2 first? What is that equal to as a decimal? 3/2. What is the value of this number if you think of it as a decimal? If you divide 3 by 2, or if you take $3 and you split it into 2, in half. What is, let's say, how much each part? How much is each part?
150.
150, that's right, 1.5. So now when you turn a decimal into, or a fraction into a decimal, it makes more sense. You know exactly where to put it now. So where do we put this number here?
21 and 2.
You're gonna put that right
21 and
before.
2.
You're right between the
That's
1
right.
and 2.
That's right.
Between
Right
1 and 2.
Mhm. Right in the middle, 1.5. So if you want to put any number in a fraction, first turn it into a decimal. And then you can find that decimal easily on the number line. Then this number, negative 2.5. Between exactly which numbers do we find that decimal? Where do you find this number, negative 2.5, on the number line?
Professor, is that minus 1.5 or plus 1.5?
Minus 2.5.
No, before the one you put 1.5. If it was a minus,
No, it's just a fraction. 3 over 2, 1.5. It's positive.
yes, thank you.
Mhm. So where do we put this? Where do we find this number?
Between -3 and -2.
That's correct. Between
Oh, that's what I
-2.
said. I'm sorry, I was on mute.
Okay, so negative 2.5. So this is 2, negative 2.2, negative 2.5, then 3, 3.5, 4, all negatives. So that should be exactly here. Negative 2.5. What about pi? Where do we find it? Between which numbers?
Which one you said?
Pi.
Between
We
3 and
What was the question?
3 and 4.
4.
Closer to which number? Okay, which number is it closer to?
3.
3.
3. That's right, because it's just 3.1, not 3.5 or 6. It's very close to 3, right about here. Pi is very close to 1. If it was, for example, 3.5 would be in the middle, 3.6 here, 3.9, but it's very close. Very close here. Finally, 2.2, I mean, 2 to the power 2 is basically 4, which is right here. So all sorts of numbers we can find, or we can graph on the number line. If it's a fraction, we can turn it into a decimal. If it's some other sort of number, simplify it like the power and so on. So that's the number line. It has all, you can put all sorts of numbers on it. We can graph or plot all the numbers on it. Now let's see how to compare these numbers, all of these, based on the number line. How do we compare, comparing real numbers based on the number line? So all the numbers, basically some are bigger than the others. Comparing real numbers. Try to keep skipping that in. So we're gonna see how to classify or compare real numbers. All the numbers we saw earlier. So when you compare numbers, basically we just say which one is greater, which one is less than, or whether they're equal or not. Comparing positive numbers is simple. When you compare 5 and 2, that's obvious. 5 compared to 2, what is the comparison here?
Greater.
5
is
greater
greater than 2.
That's right, greater than. Or if you have, let's say, 1 compared to 4, what is the comparison? 1 is
Smaller than 4.
that's
Less
right,
than
or less.
4 is greater than 1 or less than, 1 is less than 4.
1 is less than 4. These are the comparison signs, greater than or less than. It's easy with the with positive numbers, but it gets tricky with the decimals, with the minus or the negative numbers. So the number line basically starts, we have 0 in the middle. As you go to the right of 0, the numbers get higher and higher, 1, 2, 3, and so on. But if you go into the other direction, the numbers only get smaller and smaller. So -1 gets down to -2, -3, and so on. This is smaller and all the way to -100, -1000. So the numbers, because of the minus, the value of the number gets smaller and smaller as opposed to the other direction. So when you compare two numbers, think of them about their location on the number line. The numbers on the right are always higher than the numbers on the left. So if a number is on the right, it's automatically higher than any number on the left. So that's how you should compare negative numbers. Let me give you a couple of examples from here. So for example, compare -1 to -5. -1 is here, -5 is here. So what is -1 compared to 5?
Greater than 5 is greater than
Greater than.
Greater than. That's right. That's right. So 1 is here, 5 is here. So 1 is on the right side. So it's greater than any number here. So it's greater than. Because it's flipped, not 1 and 5. If we compared 1 and 5, of course, 1 would be greater than 5, but this is the opposite. The minus, we see it flips the whole comparison. What about, let's say, -4 compared to -2? Again, look at it.
It's gonna be 4 is less, -4 is less than -2.
That's right. -4 is less than -2. -4 is here. It's on the left side. -2 is here. So -2 and -4. The number on the right is higher, or the number on the left is smaller than that. Okay, so again, think about the signs, not just the value. For example, if you see -100 compared to -3. Think about the sign, think about the number line. Which one is on the right? Choose on the left. So -100 compared to -3.
It's less than -3.
It's
Exactly.
less
This
than
is a
negative.
small number because of the negative. It's actually very small. -100 would be all the way down here somewhere. It would be -100 here. So it's much smaller than -3. And when you compare 0 to any negative number, 0 is what compared to any negative number?
greater than any negative.
That's right. So the number 0 here, as you can see, it's on the right of all the negatives. So it's better, it's greater than any number. And of course, it's also smaller than any positive number. So whenever you compare 0 to a negative, the 0 is always greater. It's also smaller than all the positives. So, okay, that's a comparison. It's pretty simple. Just be careful when you compare the negatives. Don't just look at the value, look at the sign as well. Okay, so that's a number line. We use it to graph. Just to understand graphing, we use it to understand the comparison. And we're also going to use it now to understand the signs. We're going to use it to understand all the signs of adding, subtracting, or at least adding and subtracting, not necessarily the multiplication. So let's start with addition, subtraction, the rules and everything. Later, we're going to do the multiplication and division of the real numbers. Again, real numbers are the numbers, are all these numbers here, natural and so on, all the way to irrational. So to understand those operations they mentioned in the beginning, like -2 + 5 or -1 - 3, we're going to need a number line for that. So let me draw another line. So this would be -3. So this is adding and subtracting real numbers. Again, it starts with a
Hello?
straight line.
Hi.
Hello, are you talking to us?
Yes. Sorry. I was trying to see if I was on mute. I was making sure I wasn't. Sorry. Because something is going on with my computer and I can't see you guys. So just give me a second.
The number line again, it has 0 in the middle. We have some positives. Again, just like a ruler or measuring tape or whatever. It has a scale of some units here. So for example, so on the other side, you have negatives. Okay, so the number line. Now we're going to put all this on it. I'm going to try to understand the addition and subtractions using the number line. Let's start with something simple. For example, 5 take away 2. We all know that's 3. Or maybe even, let's say, 3 plus 1, that's 4. So these are simple, we know them. These are pretty much the operations we've been dealing with so far, but we haven't done, for example, negative here or negative here. It would be different. So let's see this through the number line, and then apply that also to the numbers with the signs all over the place. So when you say 3 added to 1, basically, if we use the number line, we say start from 3, then go up, go to the right once. So the number goes up. Adding means going up or going to the right, because the numbers go up to the right, they go down to the left. So 3 plus 1. So 3 is here, and plus means add 1 to the right, or 1 step to the right. So start from here, go 1 step to the right. So we end on 4. That's why we have 4 here. Same way if we're going to do the subtraction. So we start from 5. We're going to drop, or we're going to decrease the number by 2. So minus means go to the left 2 units. So start from 5, go to the left 2 units. Here is 5, go to the left 1, 2, 3. Now we have 2. Hold on, we start from 5 in 1 and 2, right? And we end on 3. That's why we have 3 here.
Professor, so we don't have to put -3, like 5 minus 2 is -3, like that, no?
No, 5 minus 2 is 3. Okay, and again, we start from 5, we go to the left twice. Start from 5, then 1, 2, and we end on 3. So these are obvious, no problem with these. But this gets interesting when you have, let's say, 2 minus 3. So that's a little unfamiliar. So this is something we're not used to, but if we use a number line, we can get the answer, the right answer here. So think about the number line, think about the moves. What is 2 minus 3? What's 2 take away 3?
1.
Minus 1.
Minus
1. Negative 1.
That's right, minus or negative 1. So again, you start from 2, which is positive, it's going to be here. Then again, if you're subtracting, you need to go to the left. 3 units. Start from here, go to the left, 3 units. If it's positive, you go to the right. So start from here, then go to the left, 3 units. 1, 2, 3. So that's why when we say 2 minus 3, and we say it's -1, if you're wondering why, or if it doesn't make sense, this is why. This is exactly why. Think about the number line. Adding, we go to the right. Subtracting, we go to the left. And the number may decrease or increase depending on where you're going. Okay, so it is another one that may not make sense, but we can do it with the number line. Let's say -3 minus 1. What is that equal to using the number line?
-4.
Say it again, I'm sorry.
-4.
That's right, -4. So you start from this number.
Yeah.
Then you go to the left 1 time. Start from this, happens to be negative. Because we have a minus here, so we're going to go once here. Once to the left. That's why it's -4. So now, hopefully now these make sense. So next time you see this, you wonder why it's -4, why it's not 3 minus 1 or positive or something. Think about the number line, think about the moves we make to the right or to the left. And that's where things come from. Okay, everybody, does that make sense? Okay, let me give you another one. Let's say you have -3 plus 2. Again, don't guess the answer. Don't just do 3 plus 2 is 5 because you see a plus here. Think about everything, think about the signs, but not both numbers, think about the move. So do it on the number line.
-1.
It would be -1, that's right, because we start from -3, which is here. Where do we go from -3?
To the right.
To negative.
That's right. Start from -3, go to the right, 2 steps. Start from -3, 1, 2, and we get -3. That's what happens with these weird signs. We call them signed numbers. They don't make sense. These make sense. We can do this without a calculator, but these, a lot of people get confused when they see these, and they don't know what to do with whether to add or subtract. You just look at it and basically panic. But today, after this, we're gonna conclude a couple of rules. We're gonna write a couple of rules based on this, so we can apply those rules every time without needing the number line, without having to draw the number line every time. Let me give you one more here, one more example. -5 minus 2. What is that equal to?
-7.
-7.
Oh.
So you see there's a pattern here. There's a pattern. We're going to see what that pattern is, and we're going to use it. We're going to use that pattern to draw some conclusions or some rules. What about -2 plus 7?
-5.
5. Or
Five.
+5.
Or would be
Positive
-2, that's
5.
right. Or would be +5. Again, if you start from -2, you go to the right 7 units, start from -2. You can go 7 units, 1, 2, 3, 4, 5, 6, 7. We have 5. But again, don't worry, we have a rule for this. We're gonna make a rule out of this. So if you try, for example, to do 450 plus 725, so it doesn't make sense to use the number line here, because again, there's a lot of numbers here. You don't want to draw a long line with many numbers, but we can conclude again, there's a pattern, there is a rule here, but we can apply to the numbers without using the number line. So let's see how to do that.
So is minus -275?
Well, let's see. Let's first
This plus.
let's do a couple of rules, and then this will clear things out. So let me take a couple of these and we will apply them. So if you look at especially here, these two here, what happens to the sign, and how do you get the 4 without looking at the number line? So ignore this, just ignore the number line now. Just try to understand the pattern here, so we can do these without using the number line. So you see that the sign stays the same. What about the value? How do we get this value from these two numbers?
Because 2 equal signs, you add, and then you put the common sign, which is
that's
negative.
right. So the same sign here stays the same. And it looks like 4, we got it by adding the 2, even though it's a subtraction here, but we kept the same sign and we added the 2. What about when you have two different signs, for example, here or here? Which sign did we choose and why?
The higher sign.
Right. Say again?
I said the one is higher than you.
So it looks like we have different signs, right? But we picked one over the other. Why
The
do you
one
think?
that is
One is
greater
larger than the other.
other.
Yeah, it's a
Correct.
priority.
Correct. So basically we use the sign here of the larger number. So we have two signs. If it's the same, it stays the same. But if it's two signs, two different signs, one of them, we gotta pick one of them. Usually we pick the sign of the higher number. So each number, think of it as has a sign to the left. 7 has a sign here. This has a sign here. Each one has a sign to the left. So if it's the same sign, it doesn't change. But if there are two different signs, we have to pick one. And usually the one with the higher value, the sign of the higher number is the one that wins the difference here. Okay, that's good. So we got the sign. How about the 5? How do you get the 5 out of these two numbers? What is the the operation that you do. How do you get the 5 out of these two here? We said
Because
that
two
7 minus
different
2.
signs, two different
That's right.
signs, then you subtract, and then you put the higher, the sign that is higher, the number that is greater than the other.
I will
That's
do
right.
7 minus 2.
That's right. So if you have different signs, you got to pick one, the higher, and then you just do the difference of the two numbers. So ignore the signs at that point. After you get it, just ignore it and just get the difference of the two. Difference, as we saw previously, means subtraction. So the difference of the two numbers, the larger minus the smaller. The larger minus smaller, you get the value. Here again, if it's the same, it stays the same, but we add. So we add here, we subtract. So those are the two rules that pretty much solves all these problems without looking at the number line. So there's two rules, either different signs or same signs. Let's write those two rules here. So number one, same signs. So this only applies to addition and subtraction. Do not confuse this with multiplication and division. We haven't seen those yet. We're going to see them after this, but they're different. They're not like this. They're completely different. They have their own rules. We're going to see them later. So we said same signs. We keep that sign. Okay, keep the sign. Keep the sign. Same one we talked about here. And what is the operation again? What do we do with the numbers to get the value? What do we do with the numbers to get this value?
We add.
And add. Okay, so keep the same sign and you add the two numbers. Unlike here, here is the opposite. Here we gotta pick one sign because they're different. We gotta pick one. We pick the one with the higher number, and then you find the difference. You do not subtract, but you find the difference. So same sign, keep sign and add. Keep same and add. The other rule is this: with
Professor.
different signs.
Professor,
Yes.
please, can you show me, because if I want the graphic, because I know it's minus 2 plus 7 is 5, but in the graphic, show me how you do it in the graph.
So you start from -2.
Yeah, to get, yeah, to get.
And then you go to the right 7 times. To the right 7 times. Start from here. 1, 2, 3, 4, 5, 6, 7.
Okay.
And here. Okay. So different signs. Okay. So different signs again. Which sign do we keep? We need to have different signs like this.
The one that's higher.
That's right. Sign with a higher number. Keep sign of higher number. And what is the operation? To get the value. Here we add, but for the second one, subtract. In other words, if they're different, do the difference. You can remember it that way. If the signs are different, do the difference, which means subtract. If the signs are different, maybe remember it that way. Different, do the difference. Same, add. Same sign, keep it and add. So just a different sign, keep sign, and or keep higher, actually, keep higher and subtract. So these are the two rules, okay? We concluded these based on that. We understand why we say that because of this. So we saw it. We practiced it here on the number line by moving to the right or to the left to get these. So this should make sense because of the line. And the pattern here is summarized in these two rules. So this is why you need to remember these two rules. Don't worry too much about the number line. You're not going to need to use it every time, especially if the numbers are big. It's not going to help to use a number line. Instead, we have the pattern here. So we understood the rule of the pattern. or the formula. So that's the formula that we're going to go by to do any numbers, even large numbers, thousands or the hundreds, whatever, as we're going to see in a moment. We can just look at this, so we ignore this. We use this just to understand what happens. Okay, so let me give you a few examples of maybe different numbers, different signs. So let's say you have, let's say negative 100 plus 400. So again, it's not going to help to use the number line, big numbers, but again, we have the pattern. So first, choose one of the rules and then apply the rule. So which rule are we using, 1 or 2?
The 2.
The 2, okay, because we have different signs. Different signs, we're going to use the 2. Which sign do we pick?
Plus the higher size.
The plus.
Plus. Okay, and when you pick the higher sign, what do you do to get the value?
Yeah,
Subtract.
You subtract. So we get
60, negative 60.
300. See, it's quick.
Oh, that's 400.
Without doing with the number line. So keep the higher sign and subtract the numbers. Just subtract the meaning. We'll find the difference between the two numbers, meaning the higher number minus the smaller number. What about this one? What do we get here?
The second one, the first one.
Same
Okay.
sign.
The first one.
You
The sign.
same. And
300 minus
you keep the same.
300.
So keep the sign, keep the same, okay?
700.
700. Negative
Keep the sign.
700. Yeah,
And
yeah,
keep the
Add.
same sign and add.
700.
Minus.
700. Okay, so again, just because it's a minus here doesn't mean we're subtracting. It depends on the other sign. If the signs are the same, they stay the same. We put them together into one. If the signs are different, you got to pick one, and then you do the difference. So always try to break it down into 2 steps. First, pick a sign, then decide whether to add or subtract based on the sign. It's not always this operation. It's not always because it's plus here, we're going to do this plus this. It all depends on the sign here. Same thing here. It's not 500 minus 200. We didn't do 300 here. Depends on the other number and the sign. So if they're the same, they stay the same and they add. If they're different, pick one, pick the higher, and subtract. So this can be done again without the number line because that's the rule. This is the pattern that we saw here with the number line. What about, let me give you another example. Negative 18 plus 8. What is this equal to?
Minus
Negative 10.
minus 10.
Negative 10. Sign of the higher number. And the difference.
and
Minus.
the minus is the sign and subtract.
That's right, the sign of the higher number. What about 12 minus 7?
19.
Minus 7 is?
Minus 18.
17. I mean 19.
Minus 18. Negative 19.
Minus,
19.
minus 19. Okay, minus 19. So that's basically what do you do when you have different signs. So again, all this so far is only for addition and subtraction. Do not confuse that with multiplication and division, which we're going to see in a moment. Those are different. They have their own rules. So only these 2 rules. We should solve any addition and subtraction related problem. Any problem should be based on these. If it's addition and subtraction, if it's multiplication and division, then it's a different story. There's a different couple of rules also. There's 2 here and 2 for both multiplication and division, which we can use to solve all the problems. Okay, so now let's move on to the other 2. So these are the 2 for addition and subtraction. For multiplication and division, we have also 2 rules that are a little different. They're actually easier than these. They're easier. You can easily do those operations compared to addition and subtraction. Okay, addition and subtraction of real numbers. The rules here are simple. Everybody, I believe everybody knows them. When you times any two negative signs, this will always be, when you times any two signs, always be positive. That's right. So for multiplication, that's universal. Everybody knows it. We know this from, I believe, second grade or something. So if you times a negative and a negative, it's always positive. If you multiply different signs, meaning positive and the negative, the result will always be
minus, negative.
Always be minus. That's right. So these are the only two rules you need to remember for multiplication. They're also the same rule that's also applied to division. Whenever you multiply into negatives, it's always going to be positive. You're multiplying a positive and a negative, it's always going to be negative. So keep that in mind. Again, the same thing applies to division. If you divide two negatives, it would be positive. If you divide negative and positive, it doesn't matter which one goes first. Also here, it doesn't matter which one goes first. Division of different signs.
Is the same, right?
Huh?
So what changed?
The division of two different signs is always
minus,
like here,
negative.
Minus, that's right. When you multiply different signs, always a minus. Also, if you divide different signs, is always negative. If you divide in the same signs,
positive plus the positive still give you positive.
Yeah, so that one is obvious. I didn't want to put it here to confuse the rule. That's obvious. If everything is positive, the result is always positive. So these are the actual ones that you need to remember and pay attention to. The positives don't have a problem. Nobody gets the positives along. If you add in 1 and 2, you're never going to say -3 or -1 or -6 or whatever. 1 and 2 is always 3. If you multiply two positives, it's going to be positive and so on. So those, no need to bother with those. These are the ones you need to focus on. So 1 and 2, this is 3 and 4, or let's call them 1 and 2 also. Okay, so all the rules of the signs, and you should never get any sign wrong for the rest of your lives. If you think about these two rules, you should never get any signs wrong. As you will see, 2 here for addition and subtraction, and 2 for multiplication and division. And before you apply any rule, first make sure you ask yourself, am I doing addition and subtraction, or am I doing a multiplication and division? Because the rules are different. So make sure first you know what you're doing, then apply the right rule. If you're not sure what you're doing, you wouldn't know which rules to use. So addition and subtraction usually is pretty straightforward. As you can see here, there's nothing else. There's no multiplication here. There's no division, no parentheses. So it's all addition and subtraction here. If you have multiplication and division, you will see them, or you'll see something that refers to them. For example, for multiplication, it could be written in different ways. For example, you may say -5 times 2. So that's clearly a multiplication. So you know you're going to be applying these rules, not these. These apply to addition and subtraction. So multiplication could be written this way, or it might be also written this way. Okay, so there's nothing here, as we saw before with the order of operations. What is the operation here between 3 and the parentheses?
Multiplication.
-6.
Multiplication. So that's another way. So this is not a subtraction. It's not 3 minus 2. This is a subtraction, but here it's 3 times whatever this is. So first, again, make sure you know what operation it is before you apply the right rule, because each operation has different rules. It could be like this. It may also be like this. Maybe 4 or -4 times, let's say 5. Okay, same thing here. If you don't see anything between a number and parentheses, That's also a multiplication. Another form is, if you have both parentheses, of course, like this. What is the operation here between these two?
Multiplication.
That's right, also multiplication. If you don't see anything between parentheses, that's also multiplication. Finally, another one, you may have seen me use it. Sometimes I use just a period in between the numbers, not as a decimal point, but as a multiplication. See here, there's a lot of space between the numbers and the decimal point. It's not like 6.3. 6.3 would look somewhere like this, pretty close. But if you see a lot of spacing between the decimal points and the number, not the decimal point, between the dot and the numbers, this is also a multiplication. We use this especially if you don't want to confuse x with a multiplication. So if you were to do, for example, x times 5, we don't do x times 5 because that kind of looks like this. Instead, we use just this, x times 5, we say is 5x. So period is also another way of writing a multiplication. Okay, so let's simplify all of these. Starting with basically, let's actually maybe put a minus here. All right, so again, 2 steps. These are, again, multiplication and division are actually easier because actually it tells you what to do. So you don't have to think about multiplying or dividing, it's right here. You need to multiply, you just need to figure out the sign based on this. So what is the sign here first, and what's the value?
Minus 10.
Minus 10. So
Negative
the sign
10.
negative times positive is negative 10. And here?
Positive 6.
That's right. So negative times a negative, it's positive. And clearly that's a multiplication, that's 6. And this one here?
Minus 20.
That's right, minus 20. So we just need to figure out the sign again. The operation is here, so you don't have to think too much about the operation. What about this?
Plus 3.
Positive 3.
That's right. Finally.
Minus 18.
That's right.
Minus.
So yeah, so multiplication, as you can see, is really simple.
Oh, yeah.
Compared to addition and subtraction. So again, addition and subtraction, you have to decide whether to add or subtract. It's all based on the signs, whether they're the same or different. For these, it's always the same rules. The operation should be there, or you should be aware of it. Even if you don't see a multiplication, it could be written in different forms. Okay, everybody, any questions here about the multiplication? Now let's talk about the division, which is quite similar. It's even easier here. There's not many ways to write division. It's only about 3. It's only about 3 of them, for example, this. Males would be something like maybe 8. Another way of doing division, so division itself, or by 8 by 2. Another form of division, of course, is the fractions, because fractions are technically divisions. So fractions is another form of division. The division itself, or this. These are the only forms, I guess, I can think of division. But multiplication, there are different ways, as you can see, of expressing multiplication. Same thing, the rules are the same here. What is this equal to?
Negative 5.
Right. That's right, negative. So whenever you divide in different signs, it's always going to be negative. And of course, the operation is here. That's 5, negative 5. What about this? 8 by negative 2 would be?
Negative 4.
Negative 4. And finally, negative divided negative would be?
Negative 3, positive 3.
Positive.
Yeah, positive 3.
Okay.
So dividing 2 negatives is the same as multiplying 2 negatives. It turns into a positive. So no issue. There should be no problem with multiplication and division. Pretty straightforward. Again, be more careful with the addition and subtraction, and do not confuse the two rules. So a lot of you might be wondering, or maybe you were wondering before, why this didn't turn into a positive. You might have been thinking, oh, negative and the negative shouldn't turn into a positive. Not in this case, not in this case of subtraction. This is where it turns into a positive, when you times two negatives, or when you divide two negative. This has nothing to do with these. That's why they didn't turn into a negative. The negative stays a negative, and you add the two numbers. So again, before you do anything, make sure you know exactly what you're doing, whether you're doing this, meaning you're doing addition and subtraction, or whether you're doing multiplication and division. Completely two opposite or two different rules. So make sure you know what you're doing before you jump into applying a rule. First, think about the operation before you start doing the operation itself. I believe I hope that clarifies it. Does that make sense, everybody? Any questions about any of these rules? Everyone?
No question.
No
Questions for me.
Okay, everybody else, please let me know. Again, this is very important, very crucial in math. I'm sure you've seen the slides. You may have struggled with them before. This hopefully should clarify it, like I said, for you once for all. For the rest of your life, you will be using them. And they're very easy to understand. And once you understand it, actually, I always tell students this, actually, you're faster than a calculator, believe it or not. When you know the rules and you know what to use them, as you saw, these took us like a second, not even a second to get the answer. It's actually faster when you know the rules. It takes you a second or less. But if you don't know the rules and you want to use a phone or a calculator, imagine how many seconds it's going to take you. If someone is trying to pull up the phone, unlock it, punch in the numbers, that's take probably 10 seconds or 15 seconds, when you can do it literally in a second or two. So you're actually faster than a calculator when you know your rules. So the more you practice them, of course, the better. So this again is not only for this math class or for math only. It's going to be for this math class, for the next math class, for your business classes. Use a lot of credits and debits and accounts and stuff like that. In the medical field, there is science everywhere. And of course, in engineering, computer science, all that stuff. So this is, it should make your math and basically anything that comes with it should make it pretty simple and make more sense. There's one other thing, something called a double. And again, when people still have issues with the science, I still see people in college algebra and they struggle with the science. See these that you know, that I see that you know well right now, that you understand well. People still struggle with these in my college algebra classes. They wouldn't know what to do with this. They confuse these, sometimes they confuse these. And when you try to learn functions or some complex topic in math or equations, and you still struggle with these, it makes the problem 100 times harder if you still don't know the basics. Okay, it's like trying to write a book or write an essay, and you don't know basic grammar, like you don't know what a word is, what a sentence, what an adjective is. So you need to know your basics in order to use them for more complex stuff. So I hope this will make things easier. And well, as you'll see, throughout the class, we're going to be using science, every math class, well, and so on. One last thing. We saw the operations. Let me show you something about the double signs, which is different than everything we've seen. So maybe not so much, not that different, but let's see how it works. Sometimes you may see this. what is that equal to? Or even,
Is it
Is it still a positive? The first one that you wrote.
that's right.
positive?
So what we call the double signs, or this is the double negative.
Mhm.
So whenever you see this and this, again, just like we saw here, when you see, when you don't see anything between the parentheses and a number, it's a multiplication. Same thing here. So think of this as.
That will
think
be
of the
negative 1. That's the first one.
That's right. Think of this as a negative 1 and parentheses. So that's basically a multiplication. You got to times those. So negative times a negative is plus 3. Same thing here. So think of that as a minus 1 and times it by plus 2. So whenever you see these consecutive signs, they're not like this. They're not like this double sign here or this double sign here. These are not double signs. Double sign, when you see sign after sign, only the parentheses, only one parenthesis separates them. So think of that as a multiplication. So just times the 2. Use these rules, times the 2, you get a plus. And here, if you times the 2, what do we get? Negative.
Plus
times
1.
Negative 2.
Negative 2. Bottom line is 2 or double negative turns into a plus. It's different signs turn into a minus. So think about this as a multiplication. So whenever you see a setup like this, think of this parenthesis as a multiplication. So whenever you see these, first make those one sign. Once you make them one sign, then the operation can get very simple. Let me show you another example. So you have 5 minus 3. What is this equal to?
Positive signs.
That's right. So these two turn into a plus. First, not multiply the 5, multiply the signs, minus and the minus. The double negative turns into a plus. And as you can see, much simpler now. The parentheses are gone. This is just 8. What if you have this? Seven plus minus in parentheses 4. What is that equal to? Or
negative 2.
Not negative 2. Think about the double negative. Not the double negative, the double signs. Turn them into one sign first, these double signs.
Negative 4.
That's right. So this turns into a negative. So times them. In other words, when you see a sign, parentheses, a sign, times the 2. So positive times a negative is negative. And that's 3. So once you clear the double sign, it becomes much simpler, much easier like this. Okay, so this might look confusing, but once again, you simplify the 2 signs into one, it gets simpler.
Professor, I was going to ask you the 5 minus parenthesis minus 3. How do I know if it's not a multiplication and it's a subtraction?
Yeah, good question, because I thought it was a multiplication.
Exactly,
So,
I thought it was a multiplication too.
Yeah, so think of it as a multiplication here, multiplication of these 2. Okay, multiplication not of the numbers, of the signs, like we did here. Okay,
Yeah.
think of it as, let me put it in other words. Think of it, there's a minus here, right? So in the order of operations, what would you do first here? In the order of operations, what do you evaluate?
Parentheses.
After the parentheses?
Multiplication.
So you would evaluate this first, right? So negative times the negative would be plus 3, 5. When we say multiplication, it doesn't mean 5 times this. We mean the sign times the sign, okay? Sign times the sign, negative 1 times the negative. Okay, and same thing here. So that also, we have plus, think of it as a plus 1. We multiply the 2, not the 7. We multiply these 2 together. So if you multiply these 2, positive 1 times negative 4 is negative 4. Bring down the 7, this is 3. That's why we have 3. Okay, so the double sign, multiply the signs themselves, not the numbers. In other words, turn the two signs into one, keep the numbers, then see what the resulting sign is. Could be a plus or it could be a minus. Okay, is that clear, everybody?
Yes.
Yes.
So,
Yes.
all right, so again, it's pretty simple once you know the rules. All you need to know is basically this. Just this page, it has all the details. And all the issues, your sign problem should be basically solved using these here. Any questions, everybody? Any of these rules here? Any of these, everybody?
I don't have any questions.
No.
Okay,
Yeah, I'm
everybody
good.
else, please let me know.
That's good.
All right. Okay, so that's about it for this lecture. All the signs. And now we'll give you a few practice problems. Again, a bunch more. Make sure you get this because again, this is important. Simplify, evaluate, whatever the question might be. Mix things up a little bit. -3 like this. And maybe also mix things up a little bit. Okay, something like that. And also -3 multiply, give you a lot of negatives here. Let's say -1 plus 7. Divide by maybe 4. Let's see, like 18 divided by -6. Multiply -2. And finally, 5. Okay, so
Teacher,
most of
what is the number? 1 minus 2?
Yes, here.
No,
minus
here.
2, yes.
No, not that one. Then the next one. The last one, that one. 1 minus
Yeah.
2?
1 minus 2 to the second.
And the third one is 7 minus 11 or 7 minus -11? Which one?
Yeah, 7 minus 11. Yeah.
Mhm.
Okay, so most of these should be pretty quick, second or two. A couple of them may take you more steps, maybe 2 or 3 steps or so. You, by the way, use the order of operations, okay? Think about the order of operations as we do these. Order of operations and also the rules of the sign. So I mixed everything up here and make it a little challenging so you guys can know exactly what you're doing. All right, let's take a few minutes. Give a few minutes, maybe about 10 minutes before we take the attendance. I know you guys have class after this, so I'm gonna try to do this. I'll give about 7 minutes or 10 minutes for this. Okay, I would assume this should take you less than 5 minutes. Everyone should do this in less than 5 minutes. Some of you could do this probably in 3 minutes, maybe less. Okay, so give this a shot. and I'll see you in a few minutes.
Plus 3. Égal. Plus 4. Plus 1. Plus 15. Plus 3. Plus 0. Okay. Six. 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 18.
Time is up. Pencils down. Everybody, you done? Everyone? Let's go over these together before we take the attendance. So some of you, I know you have classes after this. First one, let's do this. Again, you will see it's going to be done. It can be done in a couple of minutes. What is the first one equal to?
Plus 4.
Plus 4.
Right, positive 4. And this one?
Negative.
Negative
What is it?
3.
Negative 3. And here?
Negative 4.
Negative 4.
That's right. This one, what do we do first?
Negative 1.
You're gonna do the
Negative.
It's gonna be negative 1.
This turns into? These two signs turn into?
Plus.
Positive.
Plus, right? And this will be?
Negative 1.
That's right. Here, what do we do first?
What's in your parentheses? So you're negative 1 plus 7.
This will be?
And that is
Positive 6.
That's right. Positive 6. Bring the other numbers down.
Égal à?
Have multiplication and division. Which one do?
3.6 divided by
Oh,
4.
I didn't even see that 4.
Okay, left to right, right? Left to right.
Wow.
This will be?
It's gonna be times first.
That's right, divided by 4.
Negative 18.
4.5.
Oh no.
What is it? 4.5?
5.
That's right, 4.5. And it's a negative. Negative divided positive. Another one here. We have basically a division and a multiplication. Which one we do first?
Your division.
Left to right, that's right. What is this equal to?
That is going to be
18 divided by negative. Negative?
negative 3.
Okay. Times negative 2 would be?
Positive
8. Wait.
Positive
That's
6.
right. 6. Right, the last one here, again, PEMDAS. What do we do first?
The exponential.
Nope,
What
before the exponent.
You're gonna do what's in the parentheses first, which is a -1.
First.
Right, -1 and -2.
-3.
And that made a -3. And then of course you're gonna do your exponent.
Égal
5 times
-3 times -3 equals +9.
9.
That's right. The exponent will be +9.
The answer is 15.
And then of course you bring down the times because you're gonna do times 5 times 9, which is 45.
45.
And then it's 15.
That's right. Finally, that's 50. See, so that's how it works. All these, signed numbers and complex signs all over the place, but again, with the rules and combined with all the operations, we can do this pretty easily, pretty quickly. It took us maybe 2 or 3 minutes to do all of these. Okay, so I hope you understand your signs practice. The more you practice, the better.